So today we're looking at optimizing functions, and we're actually going to be continuing on from our topics previously where we were making a polygon of constraints and we were finding vertices. What we're looking at today is actually trying to figure out when we have a real-life situation that can be represented with a polygon of constraints, how do we figure out what our most advantageous solutions are? So optimizing means our best solutions. And in some cases, what we're going to look at is trying to find a highest value or a maximum. Like, for example, maybe we have a situation where we want to maximize the amount of money that we make. We could also have situations where we're looking at the lowest value, where we want to minimize, for example, maybe we want to minimize the amount of money that we spend if we're talking about two sort of situations about a business making or spending money. So we find our maximum or minimum value by using an optimizing function. We also call it an objective function. And that's usually something that we can find within the context of our problem. So when we have a word problem, we'll have sets of constraints that give us a set of inequalities, and we'll also have some information that will let us find an optimizing function. So we'll start with an example here. A company makes windows in two different formats and is looking to maximize its profits. Each week it must make at least 200 windows, and the number of windows in format A must not be more than double the number of windows in format B. Each window in format A generates a profit of $85, and each window in format B generates a profit of $150. And we've been asked to represent the constraints as a system of inequalities, and we're asked what is our optimizing function. So we'll start with part A because that's actually what we've done before. Whenever we're trying to figure out our system of inequalities, we're going to look at our information here. We know that we have to make at least 200 windows. So if we say that X is our format A and Y is our format B, I'm laughing because there's another teacher eating snacks in the background of my class, then the way that we would write at least 200 windows would be this. X plus Y, our total amount of windows, has to be at least, or it can also be equal to 200. For our second inequality, the number of windows in format A must not be more than double the number of windows in format B. There's a lot of underlining here. So if we want to write that down, we end up with X has to be less than or equal to 2Y. So format A must not be more than double the number of windows in format B. So for this question, we're trying to maximize our profits. We're trying to make the most amount of money possible. And when we're asked to describe the optimizing function, we're trying to describe the function that will let us maximize our profits. So the information that we have here is that format A generates $85 in profit and format B generates $150. So if we wanted to write that as an expression, we would say this: $85 for every one of format A, and we have $150 for every one of our format B. That's our optimizing function. We can write it like this: our profit in dollars will be optimized by that function. All right, our second example, we have a polygon of constraints and a table with the coordinates of a few points. And our optimizing function is written as z is equal to 2x plus y. And we want to figure out which ordered pair provides the maximum value of our function, of our optimizing function. So we're going to go through each ordered pair, and we're going to use our optimizing function to find a value. So our first one, x is 2, y is 1, is actually not part of our polygon of constraints. So we're not going to be calculating because it doesn't fall into our polygon. For x is 3, y is 2, it is inside of our polygon of constraints. So we're going to use our optimizing function to figure out the value here. So 2 times 3 plus 2 gives us 8. For 4 and 3, that's actually on one of our vertices. So we end up with 2 times 4 plus 3. So we end up with 8 plus 3, which gives us 11. For 5 and 2, check again. It's also one of our vertices. We have 2 times 5 plus 2 gives us 12. And our last one, 4 and 2, is inside of our polygon. We end up with 2 times 4 plus 2. Why am I always choosing plus 2? All right. Which gives us 10. So if we're trying to choose which of our ordered pair gives us a maximum value, it's actually going to be right here, that point 5 and 2, which is one of our vertices. In our first problem, we were asked to create an optimizing function, and in our second problem, we actually used an optimizing function to figure out a maximum value. And we're going to be combining those things during our next class, so we're going to have word problems where we'll be creating our optimizing function and actually using it to figure out a maximum or a minimum value.